everybody, welcome to Logical Blah 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 Blah. I'm your host, John Maddox, and tonight we're going to be reviewing the one, the only, Dr. James Tour and his response to Wannabe Dave, that guy who said he didn't know what he was talking about in Biochem, to which the good doctor responds, boys, I'm top 50. You ain't even finished those attempts at organic chem. What is up, ladies and gentlemen? Welcome to a late night stream. John Maddox here. Hope you all have been having a great start to your week. Had a fantastic weekend and are ready to have some fun tonight as we go through one of, in my opinion, one of the most significant new components, new points in relation to abiogenesis, the conundrum that it is for the atheist Evo-Tards and the Origin of Life research community. And all of the, big talking YouTube atheists who claim they have solved this problem. Well, turns out they didn't even know this one was even a problem they had to account for on the Chiral-Induced spin selectivity, spintronics, a relatively new realization in the world of chemistry. The earliest real papers I found, like proposing the theorem, were back in 2012, and then there's been a plethora of papers published in the last 2 years on this concept. It's almost like, they figured out, like, oh, this is a thing back, I'm guessing around probably 2010, somewhere around there. Kind of realized, oh, what is this? Then this is actually real. Let's publish some stuff on it. Let's point it out. Let's start digging into it. Saw a few things around 2016, and then 2018, a couple things here and there, and then like 2019, 2020, there was a plethora of papers that were published on this particular topic. Creates just an additional layer to the chirality problem and reason for it, and another reason why the one of the previous supposed explanations for why the homochirality problem wasn't actually that big of a deal, at least according to the Evos, was that, oh, well, it could be mixed at some point, and then it just, over time, it, kind of cleaned up, and, it was a mess back then. It was all, it was a prebiotic environment, and things weren't as organized, and, it was just more of a mess back then. And then over time, things got more perfected, and supposedly somehow came to be the exquisite detail and amazing nanotechnologies that enable life to exist. But it turns out that they didn't even know this one was something they had to account for. So it should be fun, and I welcome everybody who is, if you haven't already been watching this series over on Dr. Tour's channel, I strongly recommend that you do. It is very much worth your time to go through, watch these things. It's 13 lectures and, 12, and then in summaries and stuff, but they're, for anybody who's taking the time to research and read up on abiogenesis, trust me, if you take the time to go listen to Dr. Tour's lectures, you will be getting an extraordinarily high-level explanation, detailed from a very high-level chemist who is taking the time to share his knowledge, understanding, frustration, and ultimately giving foundation to why these conundrums that are being faced in relation to what is the reasonable explanation for our existence, putting it into a whole new context. And then, of course, also giving you the opportunity to poke a little bit of fun at the one and only Wannabe Dave. We can't call him the professor because he is just a wannabe. But anyway, enough of my long-winded diatribe, folks. If you want to hop in here, we're doing a review. It's live, open mic for everybody if you want to come in. The link is pinned at the top of the side chat. I will toss it in the description as well right now. I'm going to join the stream and share your thoughts on the lecture. And all right. And let's see here. Oh, crap. Man, StreamYard is not wanting to let me put this in the description. Hang on. Well, that's annoying. Okay, well, I'll figure that one out. All right, so without further ado, let's get into lecture number 11 from Dr. James Tour Review. Anybody wants to join? There's a few people just hopped in. Click the link, join the stream, and we'll be doing a live review of this. But without further ado, here we go. Let's kick it off with chiral-induced spin selectivity from Dr. James Tour.
Elucidating the agenda of James Tour, A Defense of Abiogenesis. You can see the description box below for the link. After watching that video, I was confused and I disagreed with just about everything that Dave Farina taught. So I think that he had gross scientific inaccuracies in what he presented. And what I'd like to do is bring some clarification here. I'm going to have some timestamps in this video so that you can go back to his video. You could go back to his and see exactly what he said and see if I indeed cited him correctly. I'm thankful for Dave because he's trying to teach the masses. This is not an easy thing to do. It is something that research professors often are not good at. So I commend him in this. I don't seek to have any confrontation with Dave. I'm putting this out there to bring forth some clarity. I don't want to have any name calling or psychoanalysis of Dave or picking on him in any way. I just want to bring clarity to what's been presented. I invite other synthetic chemists to critique me, critique the work. I particularly invite a critique from my synthetic chemist colleagues and students studying synthetic chemistry and those studying origin of life. What have I presented that's incorrect? Have I misrepresented something? And if you say that I've misrepresented something, please share with me the literature article that points that out, because that would help me tremendously. How can one proclaim that? At 12:22 in the video that we're citing, a slide was shown that says not all biomolecules had to start out chiral. How can one know that?
Not all of the molecules need to have been chiral to begin with. For some molecules, like lipids, it may have been a feature that evolved later, once proteins already existed.
How can one proclaim that? How is it known? How can one just make a comment that not all biomolecules had to start out chiral to suggest that chirality could have come later? I don't know anywhere how a person could suggest such a thing, so I think that's grossly inaccurate to say that. And also showing racemic lipids, and over a billion-year period, enzymes formed, and then somehow you get chiral lipids. What does that mean, a billion years? Can you put some description on that? Time does not just solve these things. Time doesn't do that. Remember, there's no evolution here. This is pre-biology. This is prebiotic. It's before biology ever began. There's no evolution here. Molecules don't move toward life. They never have been shown to move toward life. They've never been shown to order in an arrangement that moves it toward life any more than a fully homogeneous system. So, and that's not what cells are. Cells are quite heterogeneous. So a lot of claims here that I don't know how one could know a billion years is going to solve this. I don't know how one could know that not all biomolecules had to start out in a chiral form. We'll take a deeper dive into this. Remember, homochirality means that we have one chiral species and not its mirror image. It's like the left and the right hand. The two cannot be superimposed. That's why a right-handed glove is needed for a right hand, a left-handed glove for a left hand. The two are non-superimposable. They're mirror images of one another. If I put my right hand up to a mirror, what I would see is an image of what would look like my left hand. Do we
All right, before we keep going, welcome, Bob. How are you doing? Welcome to the stream.
Hey, thanks.
Uh,
I'm doing
did
all right.
did you watch this when it came out originally, or is this the first time you'll be getting
I watched
exposed to
it
this?
originally. I'm excited to get to the part where he tells why homochirality is necessary, which I think is what he's about to do.
Yeah, I tell you what, this A was a mind blower, and B, if you,
Right?
as I kind of mentioned at the beginning of the stream, if you take the time to just go Google it, number one, you're not going to find a ton of stuff because it's a pretty new thing, just like Dr. Tor was pointing out. Um, I downloaded a paper where like the basically the presentation of the theory of the concept, and that was published in 2012. So
As
I
he was
mean,
talking about it, the concept of an inductor came to mind.
oh, you talk about the concept, the spintronics concept, and everything.
Yeah, you know what an inductor does?
General concept. Why don't you explain it to the audience so everybody knows what you're talking about?
Okay, so an inductor is basically just a coil of wire. Um, And what happens is when DC flows through it, it creates a magnetic field. It has to do with the electrons moving in a circle or in a spiral fashion. That creates a magnetic field.
So you're explaining how we used to when we were kids. You like wrap the copper wire around a magnet and spin it. You would be creating the field. Is that kind of like the dumbed down version of what you're talking about?
Yeah, actually, I think it's AC that makes the magnetic field. I forget. It was like 8 years ago.
Yeah, it's it really is interesting, and it's showing. We're getting a little echo from you, Bob. The it's interesting how it shows the with the spintronics, and Dr. Tor's going to explain this in a minute, but it's like you have two opposite directions. Like you, if you don't have it, you don't have it, man. Like this is there's no way around it. The but yeah.
Yeah,
Oh,
I don't usually have an echo. Can you try muting while I talk? Test, 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 test. Yeah, it's not. I think it's something on your end, John.
I don't know. It happens when I'm not around too, though.
To me,
Now we get a strange sound for you. It's like we're good right now.
It only
Jamie,
seems to happen when you're both on.
I was loud, Jamie. Welcome to stream, man. How are you?
Sorry about that. How was your flight?
Flight was
yep,
good.
it's on your end.
Flight was good. The yeah, it was good. It was weird. First flight I've been on since all the madness of 2020, and it was very strange. Everybody wearing masks, very quiet. Nobody was talking. No interactions really. It's kind of weird.
Yeah, that makes it
This poor,
harder to deal with.
this poor little kid. This little girl was she. Okay, I'll put you this way: she barely came up to the armrest. Okay, and she's like walking down. Well, I mean, she's like sort of walking. I mean, just real slow. Anyway, and they're like, "Oh, sorry, she's gonna need a mask on." And it's just like this little kid's maybe two and a half tops,
Oh man.
and it's having to put a freaking mask on while flying. I mean, this is just yeah. Anyway, that's a whole other conversation. Let's get back to Dr. Tour.
We really need homochirality. Those that suggest that biomolecules need not have started out in a homochiral form appreciate neither the precise alignments needed for chemical reactions, such as RNA to protein synthesis, nor have they any idea of what homochirality does for reaction chemistry pathways and yields. When one is talking about aligning molecules in RNA, for example, messenger RNA, this assembly that's needed to build proteins, one has to have a very precise alignment. If there was no chirality, there is no alignment. This will not work without chirality. But even with this, there are reaction chemistries that only can be performed in high yields when dealing with homochiral systems. To suggest that's not the case is to not understand what's actually happening in a cell. Have they computed the thermodynamic cost or assessed the inefficiencies of syntheses when performing organic reactions devoid of homochiral molecular environments? No, they've never done this. Some people just spew out this information as if it's just fine. to say that homochiral molecules need not had to have been there from the beginning. There's no way that they can know that, and work on cells suggests that that could never have been done. The precise alignments would not have been there, and the yields would not have been there. And we'll get more into that. There's an enormous entropic cost in building and maintaining homochiral molecules. Natural systems, biological systems, cells use homochiral molecules. That's costly to do. To date, we have no idea how prebiotic systems made homochiral molecules. We just don't. And we are just beginning to understand why this enormous entropic cost needed to be paid up front before the cell could ever be working. We're just beginning to understand that. And these homochiral molecules, these systems are necessary. And to just say, well, they formed homochiral systems on a chiral surface. Show me the chiral surface and show me the EEs that are gotten. This is done in a pristine laboratory, but show me that chiral surface and let's look at the enantiomeric excesses. We already looked at a whole video on homochirality, and we showed how people can misinterpret the literature where they said you get predominantly one enantiomer crystallizing out and predominantly the other enantiomer in the supernatant solution. Whereas it turned out there was only about 1% of the materials crystallized out on top of another and mixed in with another crystal. And that was at 23% EE, less than 1% yield, 23% EE. If you have less than 1% yield, 23% EE of that thing that is less than 1% yield crystallizing out, the supernatant is essentially racemic. By the standard of any measurement, that thing is going to be racemic. So there was a gross misunderstanding of the literature on that, but that we already discussed. So we want to move toward the construction of a cell. You don't want to use a eukaryotic cell. You want to use a bacterium because that's simpler. Okay, we'll just take a bacterial cell. Using prebiotic relevant methods, we have not figured out how to assemble a functioning cell. That's not been done. In the next video, we'll talk about the assembly problem. We have not figured out how to make the 4 building blocks in anything that's prebiotically relevant. To say that we have machines that can do this using purely synthetic methods in non-aqueous solvents is irrelevant. It's how was this done on a prebiotic earth? Now, even with all of our machines and all of our advances, we've not been able to assemble a functioning cell. Never. Now, with our advances, sure, we can make the 4 classes of compounds when we get the monomers, when we get the building blocks for those from nature itself. So here's the compounds that we have to make. There's the 4 building blocks, the carbohydrates, which we looked at, peptides, which we looked at, nucleic acids the same, and lipids the same. So we've already covered those 4 building blocks. What we've said is we've not even figured out how to make the building blocks of the building blocks. So there's the building blocks of the building blocks. The monomeric sugars are needed in order to make the carbohydrates. Show me in a prebiotic method how people have made glucose. Show me that. Show me how that has been done. Or fructose. Show me how that has been done. Or ribose. Show me how that has been done. Where you can get something where you get it in a homochiral form, separated from all its other diastereomers and its other enantiomer. Show me where that's been done. It's not been done. It's not easy to address these in homochiral form. Amino acids.
So, quick sidebar. The Refined Living sent me a paper earlier, or an article. I haven't found the paper on how they've supposedly created a self-replicating or a replicating tRNA-like molecule that they designed, used a synthesizer to create, and then constructed a binary code they wanted it to replicate. They then proceeded to figure out, oh, we can do this if we rapidly heat and cool it. And went through this whole process. And then after I read through the paper, after going through all this stuff, like how they designed it, created it, structured it, guessed on what would be the most likely way it would occur, created a code, instantiated the code into the sequence, and then controlled the environment and managed to get it to copy. And then it's like, oh, well, this could be potential explanation for how tRNAs ultimately formed. It's like, you gotta be kidding me. You guys actually published this, not in terms like, hey, cool, you made the process is cool, but I mean in the context of what about what you guys did and are now publishing, what does that have to do with abiogenesis research? I mean, what? is the point? How do you even like put it into that context? And I think it goes back to like what Dr. Tour's doing here of and the whole point of this lecture series, right? Is what the heck is going on in academia? Like you guys keep publishing this crap, and cool, it might be really cool synthetic chemistry, but what relevance does it have when you guys can't even figure out how to build the building blocks, and then you're using synthesizers to create different sequences to use in one of your little fun experiments? It's amazing.
Yeah, and what informed it too, as far as what could work or what would ultimately work, is I imagine it would be from studying the subject in the first place.
Well, I mean, it's knowledge of, it's knowledge of chemistry. I mean, that's what it boils down to. Like, oh, cool. If I understand chemistry, then I might be able to create something like that. And that's the irony for me of what they keep figuring out is like, oh, if I have foreknowledge of the likely outcome, then I can create an environment in a scenario in which the predetermined outcome that I'm attempting to achieve has reasonable expectation of success. Like how that does anything other than provide further substantiation of the premise of the necessity of the intelligent agent. It's like, do you guys not think about this as you publish its origin of life through undirected process? It freaking blows the mind.
Yeah, just imagining that it could be natural somehow does not really prove it. I mean, it could help substantiate a plausibility if it were plausible, but the question is, after you've applied all this knowledge and these processes, is it really plausible that it could happen naturally? That remains to be seen. It seems to be not the case.
No, it's not even. It's so
impossible.
It's so incoherent. I just, it blows my mind. And sidebar, everybody, and thank you for everybody who's doing super chats right now. I greatly appreciate it. The Redefine Living super stickers, thank you, man. George is. Appreciate it, George. But yeah, see, this is what you got to do to get George to go on a super chat matchmaker campaign. You have to, give him guilt about not joining streams, and then makes you feel better. Yeah.
You do believe, though, that it is possible that you could intelligently design a experiment that could help give plausibility to something being natural, but it's not in this case, right? That is kind of an interesting question about experimentation by an intelligent agent. Can you show?
Well, if the question you're asking is, do I think it is plausible that intelligent agents at some point could create life? Yeah, I think that's totally plausible. I mean, given enough time, the intelligent and enough experimentation, intelligent agents might be able to figure out how to pull it off.
Yeah, if we understand it enough. I was more saying, like, is it in principle possible for an intelligent agent to design an experiment that would show, it's plausible for something to have happened naturally that they've done in the lab? Some people say that that's not the case, but I don't think that's necessarily the case. It is here.
Yeah, well, this is not my assertion, but it's my, what's the right word for this? I don't know. It's late night. I've had a long day traveling. I guess my gut feeling is that, like everything else they've done so far, they're just going to continue to find that the plausibility of this being done without intelligent agents is just nil. I mean, let's get real. At this point, it's already nil in terms of being
the information alone.
The information alone. But I mean, as Dr. Tor's pointing out on this, it's like we don't even have to go that far. Like they're not even there yet. Like right at this point, it's now we're arguing over whether or not you can, if we can create a transistor right now, before even arguing about whether or not you're going to be writing software. Right. we can't even create a circuit yet. The microchips and it's like, or I guess vacuum tubes. Let's go back to vacuum tubes, like old school style, right? Like we can't even create the vacuum tubes, and they're talking about like, oh well, no, we can totally come up with a hypothetical that explains where Windows came from, It's
The
like,
thing is, I mean, that's one of the things is like the vacuum pump that James Tour talks about. Like, where are you gonna get this process where you can freeze dry something? I don't
well,
know
and
if it's in this episode, but there's one chemical where to you have to freeze dry something with a vacuum pump to get a specific process to occur, or and then you have to put it in a centrifuge, and then you're like, well, okay, where'd they get that? Where was that on early Earth? How did it get transferred from this hypothetical vacuum pump to a centrifuge, and then it's heated to 150 degrees for 10 minutes, and then it's cooled down to 60 degrees and stirred for 15 minutes, and then it's left to settle. All
Yeah.
these processes, you're like, how you need to come up with some hypothetical situation in which these things could actually happen in line with one another without um, without corruption or contamination in
Yeah, there's
transit
different
between the
stuff.
systems.
yeah, here's the, in different debates, I've used this example before. I'm like, do you actually think that it's plausible that all of the steps in the chemistry, all the steps in chemistry that are necessary to create a can of paint, do you actually think it's plausible those will all occur and you'll end up with freaking paint in a can without an intelligent agent? And then the occasional extremist will be like, well, there's always some hypothetical, and it's like, okay, well, you're an idiot then. But the majority of
We see.
people, the majority of people will be like, well, probably not. That's not reason. Yeah, no, that wouldn't happen. And I'm like, okay, then. So if you don't think that paint could form itself, which in the context of irony of ironies, like the paint requires biological components, which is ironic. But the like, so you don't think that that could form itself, but you think something that is has exponentially more complicated steps that are required, not just reaction. It's like, so we agree that the chemical processes which are necessary to create the paint, they follow the rules of physics and chemistry, but you don't think that those could do themselves. But you do think that the ones that also follow the laws of physics and chemistry, but also just have ridiculous amounts of steps that must be done in the correct order at the correct time in order to pull this off, you think those can do themselves. It's like it makes no sense whatsoever. But all right, we've been rambling. Let's go on. Let's keep going so we can actually get into the.
Wait. What's funny is we're talking about how cells are a factory, right? But when we're listening to James Tour's series and finding out that you basically need a factory to build the original base components that make this factory.
Yes, yes, it is. It is the ultimate irony, the proverbial chicken and egg problem that nobody wants to talk about.
Maybe the factory evolved.
I mean, at this point, why not? Oh, sidebar. Actually, another video I will have to review soon. I watched it the other day, or listened to it. Actually, I didn't watch. I listened while I was driving to Florida. The Nobel Prize winning researcher on ribosomes gave a big lecture on the ribosome, how cool it is, all the stuff it does, and then went into her supposed explanation for abiogenesis, and literally was arguing that if there was coevolution of all these things, then life could exist, and that was how that was her explanation for life. So you're conceding that you have to
That's an
have.
argument for intelligent design.
I mean, exactly. Okay, let's continue.
Show me where homochiral amino acids have been made. Nucleotides, the sugar problem. Because in order to make a nucleotide from which you make nucleic acids, you have to be able to make the sugar. Right there is the sugar. So you have to have that ribose. How do you make ribose? Has anybody ever made ribose in chiral form using prebiotic methods? And even if they could, then build that building block. Show how that would be made. Glycerol. Glycerol is not chiral, but what it has is it has hydroxymethyl groups that are enantiotopic, and those have to be selected in order to get that chiral. So the big problem here is we've not figured out how to address homochirality. That problem has not been solved. in any prebiotically relevant method. And remember, we can't play these games where we make something that's a little blip, then we say, oh, there it is, it exists there, so now I can buy it. No, can't play those games. Prebiotic Earth could never do that because there's all those stereogenic centers. So when you have these monomeric sugars, you have these 4 stereogenic centers. There's a stereogenic center here, but this is where the glycosidic linkage would occur. This can be alpha, as shown, or beta, and so that is variable, but it still has to be controlled. So you have all of these stereogenic centers. Amino acids, 19 of the 20, have a stereogenic center. And so this is what we've got to be able to deal with. Nucleotides, the sugar problem, you've got 4 stereogenic centers on this RNA nucleotide. These are enantiotopic hydroxymethyl or hydroxymethylene groups. These are enantiotopic, so they have to be desymmetrized. They have to be distinguished. That's, again, we need some sort of chiral environment to do that. We can't even make the simple class of the lipids. We don't know how to do that. All right? So, therefore, did homochirality occur after a simple cell formed? Maybe the cell was running on racemic mixtures, running poorly, and then somehow they got cleaned up. We have no idea how that cleanup could have occurred, but could a cell even operate with racemic mixtures? What we're talking about today is chiral-induced spin selectivity. This is a phenomenon that was first discovered about 20 years ago by Ron Naumann, and some of his co-workers have really developed this now. I think this is going to receive a Nobel Prize in a decade. And this is an amazing phenomenon that most chemists don't even know about.
Okay, so that's very interesting. The first papers I was finding were from 2012. Dr. Torr said it's been known for, what, 20 years? So even though we're talking, so they discovered the concept around 2000, around the turn of the millennium, and then are just now starting to really kind of develop the concept. That's interesting.
Certainly synthetic chemists don't use it to their advantage, and I'm sure that the vast majority of biologists know nothing about this. The chiral-induced spin selectivity, or CISS effect, relates to how electrons travel through chiral molecules. Electrons have the properties of A, being negatively charged, and B, spin. For spin, you can consider it as an electron having a spin up or a spin down orientation, or rotating clockwise or counterclockwise, as an analogy. Professor Ron Naumann and David Waldeck and their colleagues have found that when electrons go through chiral molecules, one state of spin is preferred over the other. Usually you get this spin state selection only with magnetic materials, particularly ferromagnetic materials. But chiral molecules are not a magnetic material. Yet still only one state of spin can be transmitted through them, or one state is highly preferred. This reveals a hitherto unappreciated role for the chirality in cellular function, where chiral molecules are ubiquitous to control reaction chemistry and yield. It controls reaction chemistry and it controls yield. So chiral molecules have a helical pitch about the stereogenic center and about the larger helical pitch induced by those stereogenic centers. Matched spin electrons travel through. The unmatched ones don't go through. That's how cellular systems keep such high yield, something that few have appreciated. The problem with human-designed syntheses. Here's the problem. How does chemistry deal with mistakes in synthesis, i.e. the low yields? If we get 80% yield in our lab, we think we've done pretty well. And that sometimes we only get that after much optimization. But let's take the most highly optimized synthetic reaction in the world. When I say synthetic reaction, I mean the reactions that humans have developed. DNA synthesis. Just 100 mer, 100 units, that would, say, code for, say, a 25 long segment of a protein. Just a very short protein. It takes 4 steps per addition of one nucleotide in a DNA synthesizer, which we've seen in a previous video. You have to do deblocking, coupling, capping, and oxidation. There are 4 steps per cycle. If we generously give 99.8% yield per step in these highly optimized systems, that would be 0.998 to the 400th power. 400th power because there's 4 steps and we're building the 100 mer. That'd be 45% yield. That means 55% of what we want is the unwanted oligos. 55% is unwanted. Chemists use HPLC and PAGE to purify. How would a cell deal with this sort of impure mixture? We have no idea. Cells never deal with this sort of impurity. They don't do reactions with this sort of impurity. They have very small amounts of impurity. In cellular systems, the yields are much higher. So purification becomes possible with the assistance of homochiral selectors. And they have to be homochiral to be able to select these things. How do cells promote such high yields in organic reactions? Surely with the use of CISS. So chirality had to have been there at the origin of cellular activity if we're going to be able to get high-yielding systems. Or else the cell would just fill with garbage and would be unusable. And then take it from one, I've showed you where I had reactions where we were doing templated reactions, and the fidelity of the reaction, being able to make high yields, just destroyed us because everything that was not what we wanted would end up replicating itself as well.
Game over.
Well, I agree. And the last point he made there was that everything they didn't want would replicate itself and continue. So basically, what he's saying there is, yeah, awesome, we were able to get things to replicate, but it was a little bit of what we wanted and a whole bunch of what we didn't, and this causes a massive problem, and therefore, we weren't achieving the result that we wanted, and we gave up on it because it doesn't make any sense to continue to do something that doesn't work. And and the point he made about, he kind of referenced there in terms of the high fidelity, like, what do we know about biological systems and cells? We require extremely high fidelity or you die. Like, that is just a fact. And it's a fact. Like, you have a high fidelity or you die. Period.
Yep. You can't appeal to the evolutionary, stories for high populations and lots of time. It doesn't work that way.
Yeah, I mean, it's like either you have it or you don't, man. Like, and we're talking on the molecular biology level and the chemistry level. Like, that's the way it is. Your whole like hypothetical spreadsheets with population genetics and everything else mean absolutely nothing. They're exactly what the first word was: hypotheticals. They are not remotely plausible. They have zero relevance to real world application if you cannot account for what we're talking about right now, and therefore you go back to one of the first that said one of the points I made in my very first debate on YouTube against the one and only RJ Downard was, and I've used it multiple times since, everything about your argument and is the fruit of a poison tree, and in no other context, if your entire foundation of all of your premises is the fruit of a poison tree, you lose by default. You're dismissed by default. You're derided by default. You're viewed as an idiot by default. And yet, this continues to be perpetuated, and spite of that.
Yeah, these facts are much more in line with the idea of like what SF2 that I was talking about with the model of creation. It's like it's probably better understood as something almost perfect or perfect degenerating, and that's what we're seeing in life rather than, a bunch of just throwing crap at the wall until something, good comes out of it.
Bob, before we go, great point, Jamie. Bob, before we go on, you have anything you want to toss in before we get into the CISS?
I mean, the spin selectivity is just, I mean, he even talks about magnetism when he's dealing with it. He's like, only ferromagnetic materials do this. But these homochiral molecules do, they do this. And he goes into it later. I don't think he's mentioned it yet, but it also deals, he'll go back to the chiral-induced spin selectivity and point out that it affects, there's like a heat problem in all of the chemical reactions that cells use. And I'm having trouble thinking with the echo. Yeah, so okay. The uniform spin, the chiral-induced spin selectivity that is utilized in cells reduces dramatically the heat generated. He talks about the difference between the wattage of like a human brain versus like a computer. It is, well, he'll get into it. It's just insane. It's awesome.
All right, let's get into it.
All right, how do cells keep reaction chemistry yields so high? chiral-induced spin selectivity. Did you know that? Take, for example, hydroxy radical. If you take the unpaired electrons of two hydroxy radicals, can either be aligned, parallel, anti-parallel, or parallel. So if you have two hydroxy radicals, those two can be aligned parallel or anti-parallel. When anti-parallel, they're going to go along a singlet surface that correlates with the formation of hydrogen peroxide. And they have a barrier for forming the oxygen molecule in its triplet ground state. If the spins of the two radicals are aligned parallel to one another, the system is on a triplet potential energy surface, and the oxygen molecule is favored. Chemists have yet to understand how to exploit this well in synthetic reaction chemistry. In cells, reaction chemistry yields have to be very high. Homochirality is essential for this to occur. Homochirality ensures high and selective reaction yields through CISS. The electrons proceed down a molecular pathway that correlates the spin to the homochiral twist direction. It's like a spin valve. It selects which one is going to go through. Electron transfers in cellular systems, photosynthesis, for example. Plant cells survive by photosynthesis, which have relatively long-range electron transfers. When traversing in the proper direction, where the electron spin and the chirality of the molecular architecture are matched, electron backscattering by vibrational modes of the molecule are suppressed, since they would require a change in spin and linear momentum. Hence, inelastic collisions and energy loss as heat are suppressed. This minimizes the heat release during these transformations. Many people have wondered how a cell can operate without burning up. Here's how it operates without burning up. It uses chiral-induced spin selectivity, so it minimizes inelastic collisions. And so, and that minimizes the energy loss, and you have heat suppression. Scientists use pi-conjugated molecules to get electron passage through homolumo gaps that are small. So you have highest occupied molecular orbital, lowest unoccupied molecular orbital, and we use pi-conjugated systems, sp2 hybridized carbons, for putting electrons through. I spent a large part of my career working in that area, putting electrons through small homolumo gaps of pi-conjugated systems. I've written a lot of papers on that topic, actually. On the contrary, cellular systems have primarily non-pi conjugated proteins for electron transfer. How cells do this is amazing.
Yeah, he just mentioned the heat problem and how it was required. It's required to reduce the heat of these reactions. And I don't know if most people catch what exactly is meant by what he's saying, but when you're dealing with electronics and you have a resistor, the resistor inevitably has there's loss, and that loss is converted into heat, basically. So when you can just get it in a wire, if you're pulling too many watts through a wire, and it's not thick enough to distribute the heat across the cable, then you can melt the cable or the shielding around the cable. That causes electrical fires. That's why you're not supposed to plug too many things into one outlet and all that kind of thing. So that's what he's talking about, is if they didn't have the homochiral, where it reduced the loss through resistance, the molecule or the electrons basically bouncing off and generating heat. If you didn't have that, the cells would just like melt.
Yeah, they've talked about that in the context of, man, I'm tired. What's the name? What's the term for something like just spontaneous combustion? That would actually be a real thing. Like, we would spontaneously combust. it's actually a real problem.
Yeah, they say that people actually have.
Well, no, absolutely, people have, and there's other enzymes that are involved in other contexts of like different reactions that when they fail actually do cause spontaneous combustion. It's usually involved with the oxygen, and like the respiratory process is usually what is the cause of the spontaneous combustion when those different enzymes fail that are accomplishing different factors similar to the chiral-induced spin selectivity in terms of what's the objective. That's where some of the like quantum tunneling enzymes they've been discovering recently. I say recently, like within the last 20 years. Didn't even know they were something to look for. Now they do, and it's like, oh, that's why we don't blow up. Just like with CISS, like, oh, that's why we don't blow up. It kind of puts puts so many of these things into like different context that I find so ironic when we listen to the talking heads here on YouTube. It's like, do you guys never go and read this stuff? Like, we would blow up, literally. Like, you don't think we have to account for this? You're like, oh no, let's just ignore all that. We don't need it. Time, baby, time figured it out. That's what happened. Quick sidebar, folks. So the alternative channel for Standing for Truth, Young Earth Creation. There, as a lot of y'all know, the Noah's Flood video started going viral, a couple, like 2.5 weeks ago, I think it was, going nuts.
That was really good.
Yeah, man, it was. Matt did the vast majority of that. Fantastic piece. But then it got taken down by YouTube.
What?
Yeah, there was a bunch of like copyright claims, all this kind of stuff were made on it. But today that all got cleared up. The video is back. So if you haven't already, I strongly recommend click the link that I got. Matt just posted it in the side chat. I've got it shown up here on screen. Go there. If you haven't subbed to the channel, make sure you do that. And also, quick other sidebar. If you guys want to, SFT, if you or Matt are in here still, post a link to the trailer for their new video that just came out for the Patreons. I think it's going to come live here in the next few days for everybody else. I got the chance to watch it. Fantastic. Hands down, Matt's best work so far. Matt and SFT. Fantastic work. So make sure you post that one too if you're still in here.
Okay. I saw the commercial for it. It looks real good.
Oh yeah, it's awesome. I watched the whole thing this morning. Actually, it was before I got back on traveling. So, okay, let's get back into it, guys.
About the heat problem, I find it a little disheartening that we never heard that there was a heat problem. I've never heard about a heat problem until James Tour comes out and happens to have the answer for it. Why aren't we told about the problems before?
Well, I think if you start bringing up all the, yeah, think about it. They're already trying to solve like 17, 18 like recognized paradoxes. Why do you need another one? And actually expect to continue to, maintain plausibility. But all right, let's go on.
Researchers are just beginning to understand this phenomenon. Theoretical work suggests that there can be several orders of magnitude enhancement of electron transfer in one direction over the other when the chirality of the molecule and the spin of the electron are congruent. When they are matched, then this happens. This is why reaction chemistry is so high in cells. This is why you can take two reactions. You can go in one route to hydrogen peroxide, in the other route to oxygen. How does that happen? It happens by selecting the right electron. And the correct electron is selected by having the correct homochiral system to transport that electron through. That's how cells do it. Molecular recognition is enhanced by CISS. Chiral-induced spin selectivity can enhance interaction strength between molecules of the same chirality over that of molecules of opposite chirality. How do molecules, how does one substrate get recognized by another? Because of the induced dipole interaction, the charge Q is transferred from one side of the helix to the other, and because of the CISS effect, a spin polarization is generated, represented by these black arrows. When the helical charge distribution is of the opposite chirality, its spin polarization points in the opposite directions. It points in the opposite direction, hence the arrows are pointed inward for left-handed helix. For the two helices of opposite chirality, these are two helices of opposite chirality, the overlap region in the dotted circular triplet surface is characterized by two spins parallel to each other, like in a triplet state, and it's less favorable. This is less favorable. Enantioselection, choosing a homochirality in CISS. Enantioselection designates the process of selecting one chiral isomer over another. The left hand for the left glove, for example. High enantioselectivity is difficult to obtain in a laboratory, but easy in cells. Cells do this all the time. The best of laboratory systems are usually inferior to enzyme systems. How do cells do this? This is what students have been taught for 75 years. A preferential molecular fitting causes a molecule to enter into the chiral cleft with one preferential orientation. Van der Waals interactions, including steric effects, favor one molecular alignment in the chiral cleft over another. Little else is generally taught. A molecule will approach a chiral system in two different ways, and it'll go into the lower energy manifold because of van der Waals interactions. That's attractive and repulsive interactions that can include hydrogen bonding, dipolar effects, London forces, hydrophobic interactions, pi-pi stacking, and also because of described as steric effects. Little else is generally taught. CISS reveals that more is going on, and it's not subtle in its influence. The attractive interactions between molecules of matched chirality can be higher by as much as 1 electron volt. And if we put that on a molar scale using Avogadro's number, that would be 96 kilojoules per mole or 23 kilocalories per mole over their mismatch set. When the 2 electron spins in the matching are anti-parallel, they follow the singlet surface of lower energy by about 1 electron volt. This strongly favors enantiomer selection. Preferred chiral interaction is due to neighboring spin interactions. Interestingly, the electrostatic potentials upon which they depend can interact at near the speed of light. So these electrostatic interactions are occurring at near the speed of light, much faster than the molecular movements themselves. And when you have the match set, when you have the proper spins matched, this can be 23 kilocalories per mole, 96 kilojoules per mole, more stable going in one direction than another. That's a huge effect in preferring enantiomer selection. This would not happen unless you had homochiral systems. To try to invoke life without homochiral systems is trying to do something that you know nothing about. Therefore, the way that enantiomer selection has been taught for 75 years, based mainly on van der Waals or steric effects, never captured the full story. Cells have operated with far more sophistication, and the merging of electron spin with molecular chirality explains much of the story, something that we're just learning today. Why don't cells
So something about that I find very interesting too is it's kind of a slightly different topic, but we're now realizing that there's signals being sent, it appears, through DNA, the chain, right, that is your DNA, and being sent in a variety of fashions in protein-protein interactions and all sorts of different stuff. So you got to think about that of like, okay, so we know there's electrons that are being transferred. We know that there's different things we're discovering now that appear to be signals of some kind that are being sent as well. And then when you think about it from a reaction perspective and he was making the point about things going at near the speed of light, right? When you think about like how are we being able to have some of the synchronized reactions, right? If it's all purely chemical reaction, right? In these cascades and such, which yes, they're occurring, but there's still also like we're having very unified actions taking place.
Yeah, it sounds like you can't just say it's more than just a determined code, which is enough to ask the question of how it could arise naturally. But yeah, to have the interaction through signals on top of it as another layer is just insane.
No, because I personally have always just wondered. It's something that's struck me many times. Especially as we think about especially when you think about it in relation to. Well, I use athletics as an example, right? Like the amount of synchronized physical action that is necessary for like super high level athletes and stuff, right? For what they're able to accomplish. It's things happening to near perfection or as close to perfection as you can get, right? With just the muscle contractions and the actions and the angle, all that stuff that's being executed, the amount of information that's having to be expressed in relation to like I've talked about this a lot from being a basketball player, right? Like the force, the angle, the speed. I mean, all the different things that are being done on the fly while you're flying through the air and making an adjustment, and then somehow getting the ball to leave your fingers at the exact trajectory necessary to like bounce off at an angle off of the freaking backboard into a hoop. I mean, or you're Steph Curry and you're running at full speed, stop and pop from 30, and it goes in with barely touching the net. Like, when you really contemplate the physics and everything that's required for that to happen,
Yeah.
something that humans like, whoa, that's amazing. We kind of take it for granted, like, oh yeah, we can do that. Humans can do that. It's like, yeah, I mean, we can. Are you not taking into account like the level of just mind bending tech that's required? Like, if somebody built a robot that could do a Steph Curry stop and pop from 30,
Yeah.
you would be
Yeah.
considered the greatest
They're trying to.
robot designer, engineer, whatever. Insert a crap load of titles because you'd have to have so many like people on that team to create that robot. And all with mechanics, electrical engineering, programming, all that kind of stuff, right?
Yep.
It would blow people's minds of like you'd have to have some of the most brilliant people on the planet to be able to create that.
Yeah, you should hear some of them guys talk about, like at Boston Dynamics, about the things they've overcome, and it's amazing, but it's nowhere close to the human body. And when you consider the human mind, I was just watching a thing last night. It was about like perception and how your brain, because of like the light speed and how you have to time things to like just catch a ball. Like a lot of times it's not intuitive to how you'd expect the brain to be reacting. So
Yeah,
I'll have to share that later.
Sal's talked about that in relation to when he was being a pilot and learning on those things, doing obviously engineering in aerospace. That the engineers like him recognized like just the premise of the bird, right? And the bird can zip in at crazy speed and somehow land on a power line. Right? Like we've all seen this since we were children, right? You see giant flocks of birds, they're zipping around and then they like land on a freaking telephone pole or telephone wire or electrical wire, whatever, like whatever it is, right? They're landing on or a tree branch. And we just kind of take that for granted. But again, from the calculations that have to be being done in the little dinky bird brain, in the literal bird brain, right? They're being able to pull this off, and it's something that we don't even have a prayer of doing, right? At least right now, right? In terms of our technology, even though we're trying, and yeah, our drones are getting better, and we're being able to do stuff, but we're still not even remotely close. And then the amount of engineering and programming and components and everything else that are necessary to be able to account for the speed changes and the angles and everything else we recognize that in engineering in aerospace as being extraordinarily complicated and just you have to have every piece otherwise you crash instantly, you're done. But we've got evos running around being like no, 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 quantum navigation created itself, bro. You just
There's definitely something to that, because often like just like when when your brain compensates for something, like having to time something ahead, and you have to consider the light has to like bounce back, and you have to have a signal, and then or like if you touch two places on your body that are farther away, one's closer to like you know your nervous system or whatever, like say your toe and your nose, and you touch them simultaneously, and you feel them, the sensation is simultaneous, yet, or even just like your visual sound and how your brain, like I guess when they were figuring out how to time like the audio and the video uh footage for like television, like they were worried about how that would synchronize, how well they could synchronize it or whatever and not look strange. I guess there's like an 80 millisecond, if it's within 80 milliseconds of perfectly timed, your brain like corrects for it, and so you don't really notice it. It's interesting, and it's often not how you'd like expect that to work because of like the experiments you can do to show. Well, you'd think your brain's just filling in the gap, just like for what it expects, but it's more complicated than that. I'll have to show you it. I'll send it to you.
that's very cool. Yeah, I'm interested to see how that works. That's very fascinating. All right, let's
Fun
continue on.
fact:
Welcome back. What's up, Bob?
birds either can't or don't land on power lines because they are coiled wire with AC running through them. So, like an inductor, they create a magnetic field, so the birds don't land on them.
I wonder if that's the in England. they have these like the power lines are on these like gigantic, I mean huge posts, and I think I wonder if they do something with those, like have them protected in a certain way, because I guarantee you, yeah, you're right. I don't really see that here in the States, but in England, uh, there was one that like went through the farmer's field that was behind my house, my first house when I was growing up a kid, and I used to see the crows landed on them all the time. And
Well, as long as you're not grounded, it shouldn't be a problem. But if you touch two different wires, that would be a problem.
Well, they may be data cables or telephone wires and not power lines.
No, these ones I'm remembering, they were definitely power lines because I remember seeing the transformers and everything. But they may have had them. I mean, these were freaking massive. I'm saying they may have had some kind of shielding on them that was enabling them to do
As
it.
long as you, like, if you jump in the air and grab like one of those shock things on a fence, it won't shock you as long as you're not grounded.
True, but I agree with what you're saying, Bob, and I agree with you in some kind. Like I said, because you're right. I don't really see that here in the States. It's a very good point. I'm just wondering.
Yeah, it's interesting. I wonder what they do differently over there.
In the UK, what they would have. I mean, these were going through the farmers' fields. I remember, like I said, I remember seeing flocks of birds land on those things all the time when I was a kid. Okay, let's keep going. And well, I'm gonna step away for just 1 second, and let's get in this. Hey, anybody else who wants to join? Emery, Sal, Jungle, anybody wants to hop on in? The link to join the stream is pinned in the side chat.
They could be putting radio shielding on it.
Because of chiral-induced spin selectivity, at least in large part. For an electron of the proper spin, chiral molecules show far less backscattering of the electron. This, in turn, greatly reduces the heat released from the molecule during the electron's passage. Lower heat affords any cellular system an advantage. Hence, homochirality is required. The existence of exceedingly efficient cellular routes is extraordinary. People have often wondered, why don't cells burn up? I mean, with all of this chemistry going on, where's the heat release? Because they're relating it to how we do chemistry in the laboratory, where we don't try to match the spins. Here's an extrapolation to the macro scale for an example, so that the layperson might be able to understand this. Kawabna, Bohen, and colleagues estimated that a microelectronics processor functioning with the capacity of a human brain would need at least 10 megawatts to operate. This is equivalent to the output of a small hydroelectric power plant. The human brain needs only about 10 watts to operate. Surely some thanks due to homochirality and CISS. This is amazing what cells are able to do, because they're able to work with matched spins that take them down lower energy profiles. They're able to change this and divert reactions along a triplet profile to make things that they might want to make in another way. So in summary, might homochirality have come after cellular life started, as some have suggested?
Not all of the molecules need to have been chiral to begin with. For some molecules, like lipids, it may have been a feature that evolved later, once proteins already existed.
Vast numbers of electrons.
I love how wannabe Dave. Oh, it may have just come later after proteins evolved. It's like, okay, so we don't have this problem solved. We don't have insert, a bazillion other problems solved. But we're going to solve this one in the future by having another one that we don't have the answer for solved. Oh, wait.
Without burning up.
Oh, wait. And that one also is subject to this problem. Whether it be the chirality of your DNA and RNA, or the chirality of the polypeptide chains that are required for proteins, they both have chirality requirement. So I'm not following you, bro. It seems like you're just let's just pass it on and not worry about it.
Yeah, it's we're well understood. Don't you worry. John boy.
We got this one solved. We got it. It's all good. It's all good.
Electron transfers take place in lipid bilayer membranes. Lipid bilayer membranes are huge hosts for electron transfers, and it has a lot to do with respiration. So it is baseless to summarily dismiss the need for lipid homochirality. That has been dismissed without base. that has just been thrown out there in a fallacious fashion. How did the proteins noted above become homochiral when there is no prebiotically relevant route ever shown to make the amino acids in homochiral form, or to separate the enantiomers, or to polymerize them? Show me the chemistry that polymerizes amino acids in water when you're doing a condensation reaction. Show me what you're going to do with these unprotected amino acids and how you're going to pull this thing together. We'll talk more about that in the next video on cell assembly. And we've already talked a lot about that when we talked about the peptides. So again, to just throw that out there, it was totally without base. There's no evidence for claimed racemic mixtures, meaning no homochirality, being usable in cells. There's no evidence for that. They have never been shown to function based on the reaction specificities, yields, and heat management that would be needed for cellular systems. Right from the beginning, we have no idea how it could have happened any other way. There are too many unknowns. All the alignment that has to take place, and now CISS nails it for us. This is how we can go down reaction potentials without having so much heat release. This is how we can do such efficient chemistry. This is why there is such a proficient selection, enantiomer selection in chiral systems, because they're using CISS. We have no idea how life could have occurred without it. So homochirality had to have been there. But like so much that is promoted by those speaking about the chemistry of life's origin, there are incorrect claims that make the chemistry of life appear easy. Because when you just ignore everything, then you just throw this thing together. It seems really quite easy. But as soon as you start getting into the details, you're very careful about those claims. That's why people who work in the area of origin of life are much more careful than those who make YouTube videos and just ignore the details.
I love that Dr. Tour has been so like restrained on the level of just utter annihilation he could have levied against wannabe Dave. You could tell now he's like, people who make videos on YouTube. Oh man, I can only imagine how painful that's got to be.
Can I respond?
Yeah, go ahead.
Yeah, well, we may not be grounded, and we might not. We might have fallacies as explanations, but they're still explanations. So I'm playing Dave here.
You talking about on when you make your YouTube videos, Dave?
Yeah, I mean, fallacies are an explanation, and we don't have to be grounded. We can be up wherever we want, and stories are explanations.
So are you suggesting that life exists, therefore the probability of abiogenesis happening through undirected process is 1?
Well, we're here, aren't we?
That is true. That is true.
Yeah.
Well, ladies and gentlemen, I want you all, everybody in the audience, make sure to give Wannabe Dave a big round of applause for his explanation for our existence and the dismissal of Dr. Tour's explanation as to why we actually don't know what the hell we're talking about.
Thank you.
Yay!
Details that are needed within trying to build life. Let me turn away from those who make YouTube videos and speak directly to those who work in the area of origin of life. Do the organic chemists that study origin of life appreciate these fallacious proclamations by those who are making YouTube videos? Do you appreciate that? Do you think it's wise that they're out there teaching these sorts of things, promoting things that absolutely could not work? Do they appreciate how misled the lay person has become? The lay public has utterly been misled, thinking that we're just on the verge of cracking this problem. Even biologists, even famous biologists, have been misled by this thing. I need you guys to stand along with me, you men and women, to stand along with me, to say that we are nowhere close. We can't make the building blocks in any prebiotically relevant route. We can't make the building blocks of the building blocks in any prebiotically relevant route that show the requisite homochirality. We have no idea how to capture CISS. Even in the laboratory, it's just beginning to learn how to be captured. We don't even know how to use it routinely in our synthetic reactions in the laboratory, let alone set up a cell to do this. We're clueless on so many points. Well, we'll end it there. If you're interested, subscribe, and we'll alert you to the next video. And the next video is going to just talk about bringing the pieces together, trying to form the cell.
I love that mic drop clip.
Yeah, that's good. That one really hits home for me. That was just each thing on its own is enough.
Jamie, what were you saying? You cut off there.
Oh, each thing you described just is so incredible. It just seems like it's enough to make people see the reality of intelligent design.
Any one episode, any one of them.
Yeah, I agree. I mean, it's yeah. Sal says episode 11 was the best in my humble opinion because it broke new ground. Now, Sal, I agree with you in the context of for anyone who's actually paying attention that it's like, oh man, there's another one. That it kind of explains in this context the overheating problem, but B also showcases its necessity and why you have to have this one way or the other or you're toast. And but so for the those of us who've been paying attention to it, reading books, reading probably papers on it, and kind of following this whole discussion for years, the things like CISS are just like, what? I mean, I'm not gonna lie. I mean, when I was watching it the first time and wanted to watch it again tonight, it's kind of like, wow, that's cool. Like, all right, that's pretty awesome. Whole new layer of conundrum. But at the same time, every single lecture, it's just like, especially for the average person who hasn't been paying attention to this stuff, each layer has got to be they got to be having their mind blown of like, what the hell have I been being told? Like, how is this stuff making headline, quote, supposedly headline news? Then the headline itself is scientists approach creation of life, understanding for our existence, that kind of stuff. And it's like, no, you don't. And I really, at this point for me, it's kind of obviously I don't really have much faith in our media in the first place, but usually my, suspicions have been more in line with politics. And in this context, it's like, do I trust the media in just about anything anymore? And B, if you're going to be either being pawns and being played by the academics, that's either that, or you guys are working in conjunction to convince people that somehow you guys have solved these problems and they, the understanding of their very existence, is pretty much accounted for. And it's like, okay, well, if that's the case, what is your end objective? You don't spew that kind of propaganda without an underlying objective on something as fundamental as your very freaking existence. That's just me.
Do you think that that because obviously as the population grows and time goes on, the more uh, facts are understood and things about biology are built upon. There's just so much to even try to learn about it. I just wonder how much that can play into people's knowledge about it and understanding it. I mean, it seems to be like open denial, but on another level, there's just so much stuff out there to learn. I just wonder how much that you can be more. It's easier to be selective. Let's put it that way. I mean, that may not be relevant to this discussion, but it's just incredible how much is out there to be learned.
No, I agree with you, and it's it's with people like Sal and SFT and Dr. Rob Carter and Stadler and Dr. Tour and Emery within his image, his image. I mean, his podcast. I mean, all these different things that people are doing. I'm encouraged to an extent. That to point you're making of like, will people be able to start to understand this more? And I think they should be able to. And I think there's kind of that catalyst that's really been. I think it started in the late '80s, but it's really started to gain snowball effect. I think since the late, I'd say since 2006, it's really been starting to gain a little bit of momentum as the level of discovery that we're making is also snowballing, right? And it's kind of how much evidence is in my favor, bro? Like,
Yeah.
I'm not gonna be playing it safe. I'm talking about from the academic perspective because everybody knows playing it safe is not really in my wheelhouse. Like, I'm not. I don't care. But I don't really have it from an academic perspective. I got nothing to lose. Like, I got some Evo tards that are gonna talk trash about me on YouTube. Like, whatever. The professionally has zero bearing for me. The like let's talk trash all day. Let's have fun. I enjoy it. It's fun for me. The For the academics, I get it. But now it's like, man, where we're coming to, like, really, you don't have suspicions yourself. Insert name of peer. Like,
Yeah.
this has been the standard talking point for a long time. But at some point, you can't just ignore the obvious.
No, there's a use for everybody in their position. And that's another cool thing about this. Like, everybody can share these different things, and we can all do a little bit to just get it out there and show the public that it's not how it's maybe seemed to you in the public school system, or just the zeitgeist of society. And hopefully it'll keep spreading out there.
Yeah, well, one of the things, just to be blunt, one of the things that I'm kind of working on, I got a little kind of video today, um, that I'll be putting up soon, about kind of what is going on in my head of, kind of next steps towards all of this. I mean, at this point, we now have, as I just mentioned, we got the evidence, we've got resources, we've got groups of individuals, both academics and, YouTube personalities and such, that are really starting to gain traction. And we've been doing it from a much more organic perspective. I think that now is the time to go on the aggressive, go on the attack. And by that, I mean the like. There's been we're up, what are we up against? We're up against the education systems, all of academia, and the media, traditional media, being against it in principle, right? So at this point, it's all right, if that's the case, then what other methods are available to us? And in the context of social media, as an example, the capital cost to begin to spread the word in a proactive versus reactive or just purely organic perspective is, I mean, the amount of capital required to start the effect is not that much. Like, you don't have to have some exorbitant amount of capital to be able to start to put things in front of people and really be operating from a strategic perspective, just like you would in business, for example, of who's my demographic, who am I going to target, what's the messaging, how am I going to communicate it, which mediums am I going to use, what's my capital outlay, what am I going to pay per CPM, CPC, all those kind of things. Like, what am I going to do? How am I going to track the ROI? Obviously, in this context, it's not ROI from a financial perspective. It's ROI in terms of knowledge, understanding, raising people's awareness, and helping them see the truth. Right? Totally different context.
Opening minds and yeah,
exactly, opening minds. But it's like, why? I really, I've said this before in the past, but one of the reasons I decided to get involved in this was my annoyance when I looked up the amount of capital per year that some institutions are getting.
oh yeah,
And I'm just like, you collectively, I'm not going to name names because they do a lot of great work, but collectively, some of the ones I looked up were getting over $100 million a year.
yep.
And
The expectations are less, and the cost is more and more every year.
between them, over $100 million in donations, right? And I'm just like, okay, from a marketing perspective, if you gave me $1 million, I guarantee you, a ridiculous amount of people in the United States of America, just as a minimum, as an example, would be aware of the ID arguments. If I had $1 million in budget to work with, I'm talking from a marketing perspective, guaranteed. And I'm like, so collectively between y'all have over 100 million And you're telling me that you guys can't, that collectively, right, couldn't come up with a $5, $6, $7 million budget in marketing to be just like blowing people's minds on all this kind of stuff that we're talking about. That especially when you have all sorts of PhDs and very highly educated individuals that know a lot of this stuff. Like, what is going on? And I don't think this is from a. I'm not saying all this in terms of attacking them. I really wonder how much of it is in the context of academics don't understand, or heavily academically dominated institutions don't understand things from the application standpoint. And I'm talking about from a communications perspective. And I really wonder if
Yeah.
that's one of the major problems that is like one of those walls that's standing in between the having a successful countermeasure towards the aggression that's being put forth by the enemy. Because at the end of the day, and this is the irony for me, is while the academics hold the high ground and whatnot, from a sheer numbers perspective, more people still believe in God, right? Like
Yeah, that's a good point.
that's a fact. So, because you know how I know that? Because the academics whine about it all the time. I can't believe all these people still believe in God. It's like, well, yeah, that's because you're the closed-minded one. Sorry. But my point being, it's like, yes, I think a lot of times people, especially that have been inside of academia for extended periods of time, I think they gain a little bit of a jaded mental state, right? Like, because in their little bubble, right, there's no way this could be spread, right? And it's like, yeah, but if you just step outside of that bubble back into the real world, you would realize that the amount of convincing that has to be accomplished to convince a staunch atheist academic versus the normal person is an entirely different paradigm. And
They don't want to rock the boat.
right, but application of that's why I go back to the whole aspect of business, right? Like application of the amount of hyper targeting tools that you now have available to you in the modern era of advertising are nuts. Like, it's nuts what you can do with it. And I'm just like, I don't understand why is this not being leveraged? It's
Maybe God has plans for you in the future for that. I mean, you could be the next Jared Kushner for ID that he was for Trump's campaign. At least the first time,
yeah. Oh yeah. That was a he annihilated him in 2016. Yeah, they never saw that coming. He was using hyper targeting, geo targeting, tagging. I mean, all sorts of stuff. They were destroying them, doing multi-layered marketing on not multi-level, folks, multi-layered. Yeah, that was pretty crazy. What was going on that one?
Hey, John.
Yeah.
God bless you and your channel. I'm gonna go. I'm gonna go yell at praise.
So, ladies and gentlemen, what's going on right now? And I may wrap up and hop over there just for fun too. There was a debate on MDD about slavery. Why? Okay, sidebar. The whole slavery debates are really getting old. They're getting real old. Same talking points over again. I don't know. That was a weird one.
I wish they would just say, you know what? Yeah, the Bible says this is the way things are supposed to be, and God said so, so shut up.
Yeah.
Yeah, it's one of those things where there's kind of two ways to argue this, and so there's strong opinions on the Christian side for either way. I'm okay with either, but I prefer just to accept the slavery thing and then explain the context. Words are.
Look, I think that people can own people, and you think that it's okay to murder babies when they're in the womb. Who's worse?
Yeah, the question is, are they willing to concede the possibility that it could be some kind of slavery could be moral in a certain context, and it just depends on what you mean by slavery. So,
Not in a formal debate, and not when it involves God, because they're atheists, they hate God, they suppress the truth and unrighteousness.
I'm not sure if I believe that the Bible is teaching that everybody knows God exists. I'm not sure I accept that. That's what it means.
Talk to more atheists, you'll figure it out.
But I just mean, psychology is a difficult thing as far as like Does someone really believe in what does that mean?
All right, hang on, guys. Okay, so let's. I'm gonna wrap this one up. Hey, and folks, ladies and gentlemen, this may be the shortest live stream I've done in recent memory. If we're gonna wrap this up at an hour and a half, so let's all head over to praises so we can observe Bob go on a tangent against praise. That'll be worthwhile. That'll be entertaining. I'm sure Jamie will head over there. I'll head over there. We'll have some fun. Um, get some never ending entertainment on praise. Okay, so folks, I hope you really enjoyed tonight's little review session. I hope you enjoyed Dr. Tor's lecture. I strongly recommend, again, if you have not seen these, go to Dr. Tor's channel. I'm going to post a link here in just a second to his channel, as well as to this video. I'm put in the description as well. Put it inside chat. Make sure you go over there. He's going to have his summary video is coming out for the whole lecture series. I think it's coming out on the 17th or the 18th. Let me check on that. So you won't want to miss that. Let's see. Just swear I just saw an announcement for that one. Where did that go? Well, it's gone now. I'm pretty sure that's coming up in the next day or two, though. So keep your eyes peeled for that. Anyway, I hope everybody enjoyed themselves. Have a great night, and as you consider the necessities for your very existence, whether it be on the chemistry level, the information level, just the general engineering perspectives, all the different components that are necessary for you to exist, I hope that you will continue to apply the principles of logic, reason, and ultimately that the conclusions you reach are logical, plausible, and probable. Have a great night, y'all.